Hello, the internet, and welcome to Open Source Directions, hosted by Quansight, a webinar that brings you all of the news about the future of your favorite open source projects. My name is Anthony Skopatz, your host for Open Source Direction. Co-hosting with me today is Carol Willing.
Hi, probability and statistics friends. I'm Carol Willing, and I'm an active member of the Jupyter and Python communities, and I'm very happy to have an opportunity with Anthony today to talk to Chris from PyMC3.
Hello, my name is Chris Fonz Beck. I'm a senior analyst with the New York Yankees. I used to be a professor at Vanderbilt University Medical Center. And the reason I'm here is I'm the BDFL of the PyMC project and currently a core developer of PyMC3, although with each iteration of the project, I am less and less involved in the actual coding. And so I'm now more of a advocate and power user than I am an actual developer. So. Happy to be.
Well, we're very happy to have you here today, Chris. And before we get started and dive into the main content of the webinar, we're going to kick off with our famous Tweet of the Week section, where each of our panelists here today will present a tweet that they've been enjoying recently. Chris, you are first up.
Okay. Do I have to do some screen sharing for this, or do I just tell you what the link is?
You can if you want. You can.
Actually, no, I don't really need to do it. So my tweet of the week is from Susanna Illich, who posted a really nice link to a tool that I didn't know that existed, but I wish I knew it existed, particularly when I was writing my PhD thesis. This is a utility called MathPix. So if you go to mathpix.com, it's a toolbar for doing LaTeX code, which in itself is nothing new. But this one, you can take a picture of an equation and it will convert it to LaTeX for you. So you can take it and paste it anywhere you like, Jupyter Notebooks, your dissertation, and what have you. And to me, it just looks like black magic, but it works even for really complicated equations. So mathpix.com, and it's currently running in my taskbar.
Cool. All right. So my tweet is actually for today's Doodle and Google Doodle, and it pays tribute to Hedwig Kahn, one of 3 women to teach physics in Germany before World War II. And she went on to teach at my alma mater, Duke. And so solidarity for the South. Works by women.
Excellent. Thanks, Carol. Nathan Goldbaum tweets, apparently attributes wrapped in a property can no longer be tab completed in IPython. I miss when tools assumed everyone was a consenting adult. And I couldn't agree more. So, well, that about wraps up our Tweet of the Weeks. And we're going to go ahead and do a brief project introduction. So PyMC3 is a probabilistic programming package for Python that allows users to fit Bayesian models using a variety of numerical methods. Most notably, it uses the Markov chain Monte Carlo, or MCMC, and variational inference, or VI. It's got about 4,000 stars on GitHub, and in March, it had about 44,000 downloads from the Python package index. So very popular.
Very healthy project. And Chris, why was the project started? Does it fit?
So the project itself was, as most of these projects began, as just some code that I wrote for myself back when I was a graduate student in 2003. And at the time, there was not a huge selection of certainly open source software packages for doing Bayesian inference and probabilistic programming. In fact, really the only one was a package called WinBugs, which at the time was fantastic. It did a great job of democratizing Bayesian inference, and it allowed be able to really easily write models in sort of a DSL that kind of resembled R. But the problem was, of course, as the name implies, it only ran on Windows. It was not open source. It was written in Pascal. It was really kind of a hard thing to for users certainly to contribute to and extend. And so, and as I was learning Python at the same time, I decided to start writing some of my own code. And back then, of course, you'd post this stuff on SourceForge, and over time it became, particularly as into its sort of second iteration and certainly into its third, started to attract the interest of other statisticians and applied scientists, and what it is today is quite, as you said, a robust community-driven package for doing statistical analysis that really has taken on a life of its own and does a myriad of things that it didn't do early on.
Yeah, that's amazing. I've actually used WinBugs in a past life, even. Pretty crazy. So, are there alternative projects to PyMC3 that are out there?
Yeah, absolutely. So now you have a pretty robust suite of packages that are available, and I guess the most notable comparator to PyMC3 would be the STAN project, and this is a package, a software project that began at Columbia University with Andrew Yeoman's group there, and it more closely resembles, I guess, the bugs package, particularly in the sense that it's the language, the DSL that it uses is very comparable to what bugs looked like. There are other packages such as Edward, which is an extension essentially of TensorFlow. So you write probabilistic programs in TensorFlow, and in each of these they do approximately the same things. It allows you to easily specify models and then fit them using MCMC or variational inference or straight up optimization. So there's a handful that you can choose from, and we love that.
Very cool. So there's a lot of different technologies that are used to make these different platforms, and I'm wondering what PyMC3 is built upon.
PyMC3 involved a complete rewrite of the PyMC project. So it did not take any of the PyMC2 code. PyMC2 was essentially a bunch of Fortran extensions that were compiled using F2Py, which allowed the package to be performant. So MCMC, for those of you unfamiliar, is a really computationally intensive approach for doing statistical analysis. It's very powerful, but it requires lots of loops and calculating complicated posterior distributions. And so it really pays to have an efficient computational backend. PyMC3 is even more so in that it relies on the calculation of gradients. And you need a package that not only does fast computation, but allows you to do automatic differentiation. And in the last 5 to 10 years, there's been a proliferation of packages for doing deep learning. And similarly, that requires the calculation of gradients to fit these complex neural network models. And so what happened is John Salvatierre, who is essentially the founder of the PyMC3 code base, implemented these gradient-based methods using Theano as a backend. And Theano is a package that started at the University of Montreal in the Mila lab, used to be called the Lisa lab, and really is one of the early engines for doing deep learning. And it has recently been discontinued, but has proven to be a really reliable backend for doing Bayesian computation, which I'm sure it was not originally intended for.
Awesome.
Yeah, well, so you seem to maybe have partially answered this next question, but who started PyMC3 specifically? Was it John?
Yeah, it was John. So he has a really nice blog. I'm not sure if he maintains it much anymore, but he was lamenting the fact that these new Bayesian methods that seemed very powerful didn't exist anywhere in available software, either commercial or open source. STAN did not yet exist. And so you really, again, only had WinBugs and JAGs and PyMC2 and things like that. And I basically offered him up the project that, if he wants to use PyMC as a platform for experimenting with this. And he took it and ran with it. And soon after that, Thomas Vicky, who continues to be a collaborator and contributor to PyMC3, essentially the three of us took it forward. And now it's 12 to 14 almost permanent developers. So it was really John who it was his brainchild, and we just provided sort of a platform for him to do his thing.
Very cool. Now, I noticed you guys have a great looking website. Who maintains the PyMC project?
Me plus one or two ephemeral developers, and really the project's been highlighted over the years as being sort of graduate students or postdocs or folks who are really early in their careers who are able to devote a lot of time to contributing large chunks of code, and then they would disappear after a year or two. And that was great, but the nice thing about PyMC3 is that we've had a lot of great developers who have contributed a lot of code and a lot of time to things like websites, and they've actually stuck around to help maintain and develop the community. And so Zhengpeng Lao, who's now a Google employee, does a fantastic job maintaining our discourse site, which is extremely active. It's the first stop that you should pay a visit to when you're looking up resources for PyMC3. And very recently we've revised our website and updated it, thanks in large part to the efforts of Colin Carroll, who's also another developer. And so we have these contributors with multiple hats. Not only are they great Python developers, they're also good website designers and community advocates as well. So we've been very, very lucky to have folks who are interested enough to contribute and stick around.
Yeah, that's excellent. And Colin in specific, I know him through NumFocus, and he's very active there. So where are your communities? Where communities do you draw your users and contributors from in general?
So yeah, I would say most developers end up started out as users and folks who just discover the package online, and particularly early on, PyMC tended to be used by applied scientists, particularly ecologists. Astronomers tended to use it a fair bit. And essentially any scientific endeavor where you're analyzing sort of medium-sized, messy observational data set. That's where ecologists and astronomers, I guess, have in common. And these days, it's expanded greatly to being used quite widely in commercial endeavors and areas outside of academia as well. But I would say these sort of applied scientists that deal with observational data tend to make up, perhaps the modal group. Cool.
Now, is the project working on any diversity and inclusion efforts?
So it's been great since PyMC has been adopted by NumFocus as sort of an umbrella organization for scientific software sustainability. And as part of that, they really emphasize the development of outreach and diversity. And that's helped a lot. So just having codes of conduct being updated, not just being boilerplate, contribution guidelines and so on. And then we also, the other thing that's nice about our group is that we're very active at conferences and symposia, both academic and not, sort of introducing our software, but then also, inviting new users to come in and contribute to the project in any way they can, even if it's not directly contributing code, but working in the discourse site or helping us with documentation. So there's more than one way that folks can contribute, and that's been great. And we hope to do more of that in the future.
That's awesome. Thank you.
Yeah, excellent. So at this point, I believe you have a demo to show us, so we get to see some fun PyMC3 stuff. Yeah.
So there's I'll show you a couple of things here. Let me try to share my screen, and we can run through a little demo using Binder. Here we go, enable screen.
Always a good choice.
Yes, indeed.
I won't complain about that one, unless it's down for some reason.
Well, that's what Twitter is for.
Here, let's do a Chrome tab. Here, right? Let's see. All right, let's start with this one. Here we are. Actually, we don't even need to use Binder. I can walk you through it because this has been rendered. On our repository, we have a large set of notebooks that have been contributed not only by our developers, but from some of our users as well. And most of them are well annotated and are good examples of what you can do with this software. This particular one is nice because it's kind of introductory, and it kind of shows the Bayesian approach to doing data analysis, which differs in several notable ways from perhaps what you learned in college in your statistics course. And so John Krushke wrote a really good book, which also a paper called Bayesian Estimation Supersedes the T-Test. And so this approach is, so the canonical approach for doing what you call frequentist or classical statistical analysis involves writing tests. So you run a t-test or an ANOVA on some data, and you essentially have a null hypothesis that you try to reject in favor of an alternative hypothesis. And there are problems with this because it's not often easy to construct null hypotheses, and p-values can be really badly misinterpreted. And so when you're using a Bayesian approach, what you do instead is rather than try to reject hypotheses, you try to estimate things that you're interested in. So if you're doing a clinical trial and you want to know if a drug is working or not, what you do instead is you try to estimate the effect size, and then you put some sort of an estimate of uncertainty around that estimate. And Bayesian methods are really adept at towards this sort of an approach. And so the example that this notebook uses actually is a drug trial evaluation, but this is a completely fictitious one. So this is just a data set of a drug that is supposed to increase your IQ. And so there's a drug. And so you got placebo and drug exposures here. And you can see, they're plotted here. There are some outlying values, high and low. And what you want to see essentially is the drug on average increasing the IQ of those who take it relative to the placebo. And what we do in a Bayesian approach is we build a model for this. We build a full probability model that describes the problem and what we're trying to estimate. And then this involves doing a couple of things. We have what's called a likelihood that describes the distribution of our data, kind of the sampling distribution. And of course, the distributions, normal distributions, gamma distributions, they all have parameters associated with them that are unknown. And it's those unknown parameters that we're trying to estimate. And so what we want to do here is describe the distribution of these outcomes, these IQ outcomes, as a function of the group that you're in. So the parameters for the placebo should have a different distribution than those from the drug if it's doing something. If they're the same, then they should really come from the same distribution, essentially. And so it involves a couple of things, picking a likelihood. So in this case, we look at this, and these don't quite look normal. They sort of do. They're sort of symmetric and peaked in the middle, but they have these outlying values. And so what we're going to do is pick something called a student t distribution. That's where the t-test actually comes from, is based on the student t distribution. And it's kind of like a normal, but it's got fatter tails. So it's a little bit more robust to these outliers here. And then the next thing we want to do is pick prior distributions for the parameters that will describe how each of these likelihoods are parameterized. And what we're going to do here is we're going to model our mean as a function of the two groups. So each group's going to have a different mean. And so here's where PyMC kicks in. What we do is we specify a model, and this model is expressed as a context manager. So we use this with function, which you've probably seen in other places in Python, namely if you're perhaps have an internet connection or a file that you're opening, you might use a with clause for that. What's going to do here is it's going to create a model, and then anything we specify inside this code block that is PyMC code gets added to the model. So it allows us to build up our model kind of step by step in a way that's not unlike what you would do if you were just writing it down, say, on a whiteboard. And so here we're going to say, the things that we're interested in particular, are the means. Is the expected value of your IQ going to be higher under group 1 versus group 2? And so we have a group 1 mean and a group 2 mean here. And so I assume group 1 here is the placebo, and group 2 is the drug. Maybe backwards. And then we're going to do the same thing for the standard deviations. So we're going to set group standard deviations, and see what we did here is we just reopened this model. So we instantiated our PyMC model and we aliased it as model, and then we're going to open it up again, and we're going to add 2 different standard deviations. So we're going to allow the standard deviation to vary as well. One simplification, so the student t distribution has another parameter called nu, which essentially corresponds to degrees of freedom. It kind of determines how fat the tails are, how many outliers that it essentially allows. And so we're going to give it sort of an empirical value here, because we're not really interested in it. We're just using it to account for that kind of extra variation. Okay, and so add that to the model.
The models are reentrant. So
what's that? Sorry?
Oh, sorry. I was just saying it's really interesting that the models are reentrant in this way. So you can...
Yeah, you don't always do it this way. Typically, if I'm working, I've just got one statement and I keep adding it. But it is really nice for teaching, particularly, and describing it to other users to be able to break it down like this, particularly in the context of Jupyter notebooks. And then the next piece is this likelihood. So here are our student t distributions, and they have the same new parameter, but they have different means and different standard deviations. We've just transformed them here. We've taken the inverse square root of them. Or sorry, the inverse square of them. All right, and we're pretty much done, except this is the nice thing about Bayes, is that the thing we really want to know, right, is what's the difference between the two? Is the drug bigger than the placebo? And so what we can do is also specify these deterministic nodes in our model, or variables in our model, that are just transformations of things that are already there. So the things we're interested in are, is group 1 mean different than the group 2 mean? Well, let's estimate it. Let's just add another node here that's just the difference between the two. So there's no extra sort of uncertainty, or there's no real additional variable here. These are just straight transformations. So what's the difference in the means? What's the difference in the standard deviation? And then you might be interested in some effect size. So the means divided by the pooled standard deviation, and those sorts of things. And you get, essentially, the nice thing is you get these things for free. We can do as many of these arbitrary transformations as we want. And then fitting the model is really easy. We try to make this as high level of an interface for users as possible. And part of that is doing some of the decision making on your behalf. And so what we're doing here is we simply call sample. So PyMC sample, and we give it a number of samples, and it auto assigns an appropriate sampler and initializes it for you. And it kind of tells you what it's doing here. And it's doing multi-process sampling as well. So it's doing multiple, essentially multiple chains of MCMC. And these can all be overridden if you want to. So more advanced users might want to tweak this in terms of which sampler it uses, how it initializes it. But it does a pretty good job, particularly for easy sort of introductory models like this, for doing the right thing. And we think that's a pretty good strategy. Do the right thing most of the time, but allow you to change things when it's not doing the right thing. And
yeah, that's awesome.
And so it'll run this for you. This looks like 4 seconds on whatever machine this was rendered on. Pretty fast draws. Again, this is a really small model with a small data set. And then what we get then are posteriors. So we had priors before, and that's what we knew about the unknown parameters before we looked at our data. And what Bayes does is it turns the crank. It adds the information from our data to the estimates of the unknown parameters and gives us posterior. So we go from prior to posterior. So posterior means after we've seen the data. And so this is what our data has told us about the parameters. And so we have estimates of group 1 mean at about 100. So these are, sorry, what does that say, 101? These are IQs, so they tend to be centered around 100. I think that's the group 1 is the drug group, and then group 2 is the placebo group, and it's closer to 100. It's kind of 100.5, but they both have residual uncertainty associated with it. And so PyMC also has functions for processing and analyzing and presenting the output in ways that are interpretable. And in fact, one of the cool things about the PyMC project is that it's generated a spin-off project called RViz, ARVIZ. And we've sort of taken all of the plotting and summary and sort of Bayesian interpretation and plotting functions and spun that out into another project that actually works with Stan and other projects as well. And so you get things like this. So you get posterior distributions, and then you get estimates of uncertainty in those estimates. So we think the mean for the drug is 101.5. It could be as low as 100.8 or as high as 102.2. And but then the thing that we may be interested most in, if we scroll down a little bit further, is the posterior estimates of the difference of the means. And so here it's plotted with a reference value of 0. So that's what we want to know, right? Is it greater than 0? Because 0 means there's no difference. Negative means that the drug reduces your IQ, which would be disastrous. And so what we see here is that there's a 98% chance that the true value of your IQ is going to be higher, with that difference being on the order of 1 IQ point. Again, this is fake, so don't go looking for this drug. It doesn't exist. But this is how you would go about providing inference. And so these are, we think, more interpretable than the results you would get from a p-value. P less than 0.01. Well, what does that mean? Does it work? Does it not? How much smarter am I going to get? Well, this is saying this will boost your IQ on average by about 1 point, but you could be the unfortunate few that maybe don't get an effect if you're out here in the tails. And you can get things like forest plots and so on, and then table summarizations for when you write up your paper that goes into Nature Science, boosting people's IQs. So that gives you a bit of a flavor, and if users are interested, you can poke around inside that notebooks directory and look. There's a whole range of examples from simple stuff like this all the way up to Bayesian deep neural networks and the likes of that.
Yeah, very cool. That's great. Carol, do you have any questions or?
No, I mean, the example, it's interesting because it seems like such a small change, but if it was something like financial, transactions or something, it could actually be quite meaningful.
If you have a lot of data, it's really easy to get really small p-values that are quote unquote statistically significant, but the effect size itself may not be very big. So is it worth taking a drug to get maybe 1 point of IQ? If you got a bigger data set, it might have detected changes of half of a point or a quarter of a point, but those changes may not be themselves clinically significant. So you really have more information using an approach like this when you're trying to make a decision, which ultimately is what you want to do with these analyses and model outputs.
Right. Yeah, exactly.
Nice.
So at this point, we'll go ahead and move on to our roadmap discussion. So at this point in the episode, we're going to talk about sort of where PyMC is going and what it's doing and how folks could perhaps contribute to the project, either via funding or if they wanted to contribute code and jump in, and how to get involved and all those sorts of things, and all the great, exciting ways or places that PyMC is headed. So I know you have a few points, Chris, if you want to go ahead and go through them.
Yeah, so this is, we sort of, we're at a critical juncture, I guess, in the PyMC project in terms of current and future development is involved. And, as I mentioned earlier, PyMC3 being built on top of Theano, which has been wonderful because Theano is very computationally efficient and performant, and it's been very stable. And one of the reasons it's been very stable is there hasn't been much new development around it. And that is finally concluded with the project being discontinued. And again, because sort of speaking, putting words maybe in other people's mouths, but I think that the project has kind of served its purpose in terms of, now there are several open source, big, robust, well-backed, well-supported frameworks for doing deep learning and the sorts of things Theano was doing that, a smaller project out of a university may not have been the best use of the developer's time. And so now Theano has since been discontinued in the last few months. And while that doesn't necessarily affect what PyMC3 is doing, it runs perfectly well under Theano and will continue to do so. Future versions of PyMC, namely PyMC4, will have to be built using a different backend. And we've spent the better part of a year evaluating alternatives to Theano. And so we looked at PyTorch, which is backed heavily by Facebook, MXNet from Amazon, TensorFlow from Google, and we've had suggestions of other potential backends as well. And what we're going to be doing is experimenting and collaborating with Google using TensorFlow as potentially the next backend for PyMC. It may not work, but that's kind of the direction we're headed right now as a project, and we've got a repository for it, and we've actually had some developer in-person, face-to-face developer meetings where we've done some planning and some road mapping and sort of exchanged ideas, and we do have isn't maybe used by applied users, but you can certainly play around with it and contribute to it. So so if you're a TensorFlow developer that's interested in probabilistic programming, we'd love to see you on our discourse and on GitHub. And so PyMC3 will continue to be developed as kind of a separate project, just as PyMC2 is run as a separate repository and project, to keep them entirely separate rather than being branches of the same GitHub repository. This makes it a lot easier because they're going to coexist certainly for several years in overlap because we have quite a large user base for PyMC3 and not everybody wants to or needs to make the jump to kind of the newest, shiniest thing.
Right, yeah. So are there issues then with, since Theano has been discontinued in terms of maintaining that into the future as you'll need it?
Yeah, the Theano team has sort of handed the keys over to us. So we maintain it, but only insofar as that it supports PyMC3. So if you're interested in further developing Theano as a backend for doing deep learning and other things, we're not who you need, and none of us are really Theano experts. We're again really more power users, and we know just enough to be dangerous and to keep things running on behalf of the PyMC project. But again, it has been really great to develop upon because it has been very sort of stable and there have been no major API changes in recent history. One of the challenges to TensorFlow, if you've been paying attention to that project, is that it's changing very, very quickly. And TensorFlow 2 will look very, very different than TensorFlow 1 currently does. And while it's exciting, it's also hard to keep pace and really even keep abreast of what the new changes are from week to week. So it's more of a challenge, but there's certainly a huge amount of opportunity there as well.
Right, and we actually had Paige Bailey on a few weeks ago. So if you want to learn more about where TensorFlow is going, feel free, listeners, to go check that out as well. Yeah, so those all sound like great places where folks could come in and help support and help move PyMC3 and 4 potentially forward. Are you looking for new contributors in the PyMC4 space as well, or is
we always are. And one of the important mechanisms for PyMC3 in the past has been Google Summer of Code. So we're entering our third summer of having Google Summer of Code students, and they have. I mean, we've had Bill Engels, who was a graduate student in Oregon, completely rewrote the Gaussian process module in PyMC essentially by himself. Max Kucherov, who continues to be an active developer, added most of our variational inference, implementing new variational inference algorithms that he's found on Archive from scratch. Just amazing. It's amazing what folks can get done in kind of a couple of months' time. And so this year we've had a lot of interest in contributors from Google Summer of Code, and those can often serve to jumpstart additional development way beyond what the Summer of Code projects do. And so we're evaluating some of those now. But even if you're not a student or you're not interested in being part of that, we're actively soliciting contributors, particularly for PyMC4, that can help us kind of make that a reality.
Yeah.
Excellent.
I'm curious, what sorts of businesses and companies are out there using PyMC3? We've talked a lot about some of the academic examples, but do you know if it's being used in government or in a corporate setting at all? And what
it is, and we try to aggregate these and kind of have a running list. I guess some companies don't necessarily want to be identified as using their software package because competitive advantage maybe, but we know. Well, Quantopian's been a big one. So a couple of Quantopian developers actually are supported by their company to help build PyMC. So Thomas Vicky being a notable one. He's a Quantopian employee, and so they use it and they do high frequency trading stuff. Channel 4 in Britain does some of this. I've heard Allianz Insurance.
Really?
That's fascinating.
So anytime you're making kind of decisions under uncertainty, where the Bayesian problems will help, PyMC is kind of there. We do have a partial list, I think, on our website, but I haven't come as well prepared with the list as I should have been. But
yeah, oh no, it's fine. I'm just curious. No need to.
Yeah, no, it's pretty wide, and you'll get hints from it. I know sports teams use it. Different sports teams have used it for forecasting and things like that.
Yeah, some folks are putting in the chat different uses like cybersecurity, risk modeling, and things. So pretty cool.
Well, are there any other roadmap items that you'd like to bring up, or is that about it?
No, I think that that pretty much sums it up. We actually have a roadmap document on our wiki in the PyMC3 project if you want to have a look at it. And PyMC3 is going to continue to exist. Folks don't have to worry about it disappearing. Again, PyMC2 still exists, and I still have to maintain some of that code. So it's not going anywhere. It's gonna we continue to spend, I think, most of our time working on PyMC3 bugs and pull requests, but kind of over time, these will sort of be developed in parallel, and some of the functionality will be ported over. An important thing is that what we're going to try to do with PyMC4 is maintain the user-facing API. Because where we fit in kind of the landscape is as this high-level interface for building Bayesian models. So one of the big new components of TensorFlow is a module called TensorFlow Probability, and it implements a lot of this Bayesian functionality, but at a much lower level. So you have to write TensorFlow code essentially in order to implement it, which is fine for some people, but not necessarily everyone. And so what we want to do is add that kind of user-friendly, again, high-level layer on top of that allows you to do the wonderful thing. Sort of like I would call it, if you want to, the elevator pitch is we want it to sort of be the Keras of Bayesian.
Well, those all sound like excellent ways for people to get involved, either with code or funding, and it's really exciting to hear all the great work that's going on, or will be going on in the near future here on PyMC3 and 4. So at this point, we're going to move on to our Q&A section. We actually have a number of questions today, so hopefully we get through them all. The first question that was sent in on Twitter by David. David asks, can PyMC3 integrate with Dask to scale out and run on a cluster of machines? And on a different note, since SMC is inherently parallel, is there a good candidate for running with Dask, and how would you use Dask distributed to take advantage of cluster? So basically a Dask question.
Well, it's an easy answer. No, it doesn't integrate with Dask at all. It would only integrate to the degree that Theano would integrate with Dask, and it really doesn't. So, I mean, if you're really interested in doing the sorts of things Dask does, then you'd be looking at, on the PyMC3 side, taking advantage of GPUs. And particularly when we go to PyMC4, of course, TensorFlow will be able to take advantage of, well, TPUs, hopefully, and GPUs. And we did, one of the suggestions for the new backend for PyMC is to build it out of something like Dask plus Numba plus Cython, whatever else, Chainer, to make sort of a community-based open source approach. And that might be a great idea too. And that might be, PyMC5 or something, because it doesn't currently, exist. So the short answer is no, it doesn't work with Dask. But that's certainly a good idea. But there are one of the things is with parallelization in Bayesian computation is that with MCMC, parallelization doesn't help a whole lot. You can run some chains in parallel and sort of do the embarrassingly parallel thing, but typically it's a sequential operation where you're calculating likelihoods over and over and over again. There are some exceptions to this. There are new methods for doing Gaussian processes that involve breaking things up into smaller pieces when you're inverting matrices and so on. But in general, you're really just looking at speeding things up through having more efficient auto differentiation and other things like that. So yeah, nice idea.
Thank you.
All right, we've got another question from Vladislav, and it says, can I use PyMC3 in a truly online fashion, i.e. use the posterior as prior when processing the next batch of data?
Yeah, so this sort of alludes to, turning the Bayesian crank. So one of the advantages that is often touted of Bayesian inference is that, you can run a Bayesian analysis and turn your priors into posteriors. Well, then what happens when you get, your next set of data? It's nice to be able to take your posteriors from your last analysis and use them as priors for your next one, and so on. And you can see how this could be online. If you have streaming data, or even if it's not streaming, just every few months I have some new information that I want to integrate, and I should be able to do that. That's sort of easier said than done in many respects, because you have to take those posterior distributions and again, in a technical sense, turn them back into some sort of prior form, which is parametric. So is it a normal distribution? Is it a gamma distribution? What have you? And certainly with a lot of data, you can actually show that your posteriors are always going to be multivariate normal, and you can turn that crank. But for some smaller problems, it can be a little bit harder. What we do have in PyMC3 now is an empirical distribution, essentially, that allows you to construct a distribution not from this parametric form, but using essentially a histogram, which is what you have when you're done, because you've got samples from a posterior distribution. So you can, in practice, do that sort of thing now using these empirical priors and these empirical distributions And then you can also use non-parametric Bayesian approaches, things like Dirichlet processes for that. So there are ways of doing it. I can't think of and maybe I know there are Colin and Ravine are on the chat here who are also core developers. They may know of an example, but I don't know of a really good example, at least in production, where that happens. But that's do as a Bayesian is kind of iteratively update your model as you get more and more information. And sometimes it just has to be manual. And that's when I do it, it's manual. Let's add some more data. Sometimes it's not worth the bother. It's kind of, sort of conceptually satisfying to turn the Bayesian crank, but often it's just easier to run the model with a bigger data set from scratch using the original priors. And you should get the same answer. If you do Bayes by spoon feeding, observation by observation versus throwing it all in one big data set, the answer should be the same. And so it's usually just simpler to run your model again from scratch, but it can be done.
Excellent, thanks.
Okay, great.
So Avhirup asks, I just started reading probabilistic programming and Bayesian methods for hackers. Could you suggest other resources for people just starting out? I think there was one in your demo, and we can certainly link to those. Any other resources in the show notes too.
So yeah, I'm going to imply by the question that it's saying just starting out with Bayes as opposed to PyMC3 specifically. If you are talking about PyMC, there is another nice book by one of our developers, Osvaldo Martin. He wrote a book called Bayesian Analysis with Python, which is a packed publishing book, and that is available. And that I would highly recommend that as well. Yes, Ken Davidson Pilon's Probabilistic Programming and Bayesian Methods for Hackers is excellent because it's this really cool concept of an open source textbook where you can actually contribute to it. And it's grown over the years. And there's PyMC2 implementations, there's PyMC3 code, there's even a TensorFlow probability version of that book. So if you want to get TensorFlow probability, you can look at the TFP implementation. But in general, just starting out with Bayes specifically, yeah, the Krushke book called Doing Bayes is really good. What I sort of call the Bible of Bayesian analysis, which is Gelman et al.'s Bayesian data analysis, which is now in its third revision, is really good. It may not be introductory necessarily, but it's written in really nice plain language, and most of the examples are very applied. Andrew Gelman is a political scientist as well as a statistician, so he's got nice poli-sci examples and psychology examples, which are easy for people to get their heads around. So I would recommend that as well.
Awesome. All right, so Monty asks, how do you add additional dimensions to a model? In this case, you might want to add IQ by gender to the model that you demonstrate.
So that model can be generalized by making those means a hierarchical model. And what hierarchical model means is that you've got parameters that themselves have other parameters. So rather than just having means and standard deviations, the means can be a model themselves. So you can model that mean as a function of, in this case, group, placebo, or drug. But then you could build a nice little linear model there. You could have other covariates, as you say, gender, city, geographical location, drug supplier.
Age.
Make it as long as you want, age. And those parameters could have other hyperparameters. You can build this kind of deep hierarchical model provided you have the data to estimate them. So that's the nice thing about it, is that you start building these hierarchical models and they can be kind of as simple or complex as the data allows you to be.
Cool. Nathan asks, since you are strongly considering TensorFlow, where do you see PyMC4 fitting in with regards to TensorFlow probability? Is the goal to have healthy competition, or are there particular advantages from PyMC versus TensorFlow probability? I think you kind of answered this a bit in terms of basically just using TensorFlow.
Yeah, that plan is to build on top of it. And so TensorFlow probability is really a library, again, built on TensorFlow that just like other TensorFlow extensions allow for different layers for doing deep neural networks, TensorFlow probability gives you probability distributions, which didn't exist. So it's got a whole suite of normal distributions, binomials, and most of the famous ones. And then things called bijectors, which is a way of mapping distributions from one domain to another. So if you've got a distribution that is only positive, like a gamma distribution, it will biject that to map it onto the real line, which allows the fitting methods to work a lot easier. So there's some kind of technical components to that. And then it's got a bunch of fitting methods. So again, MCMC and variational inference are included there. And so we will build on top of that where possible and sort of automate how it's used. TensorFlow probability may not do everything that PyMC wants to be able to do. So there will be perhaps extensions that will be in PyMC3 that are not in TensorFlow probability. But we plan to extend it as much as possible.
Excellent. And what is going to be our last question is actually a question about another library. And what are your opinions about Uber's Pyro?
I don't have a lot of direct experience with it. It looks impressive. It's definitely part of the ecosystem. So Pyro is a probabilistic programming language. Again, like you said, developed by Uber, and it's got some really smart people working for it. So no, it looks really good. And again, why have just one? Have all of these things in your toolbox, because there are things that one does better versus another that you can't always get in the same place. And some of these approaches, some of these packages use different sort of strategies for going about it. Some work kind of in what they call graph mode, where you kind of construct this directional acyclic graph and do computations over it, whereas others are more iterative, where they're more interactive and iterative, where they build things up piecewise that look a little bit closer to NumPy, which maybe are a little bit more user-friendly. And there are always trade-offs for these things, and so each of them are doing things in a slightly different way. And so the degree to which, I guess, Pyro does things that TensorFlow does, I'm not as aware. So maybe other folks in the chat will be able to answer that better than I do. But it's great to have. It's great to have just like there's Python, R, and Julia, and Rust. It's also good to have TensorFlow and Pyro and Torch and all of these things.
It's true.
The worst thing would be one package that everybody used and there was nothing else. That would be the worst part.
That would be a bummer. We wouldn't have anything to talk about either.
Yeah, this webinar series would be much shorter, for sure. Now it's time for our famous rant section, where we each get 15 seconds to rant about whatever topic we choose. Chris, it is your soapbox.
Mine is a little bit lame, I guess, but I recently switched jobs and I was given a Windows computer, and I haven't used Windows in a long, long time. And it sort of came at a good time because I started hating these MacBooks with their crappy keyboards that I'm sure everybody's read or perhaps experienced. So I thought, all right, we're going to give Windows another run. This is the new Microsoft. Their software doesn't suck anymore, or so I've heard. And I couldn't do it. I tried. I installed the Windows subsystem, or the Linux subsystem for Windows, and it's still just a huge mess. And so I've tried Chrome OS, and now I'm working again off of a big MacBook Pro. So I guess things haven't changed all that much in the last 10 years.
Well, good. You just solved my question of should I get a new Windows laptop, and the answer might be no. All right. So my rant is keeping with the Seattle theme, the Seattle TSA pre-check line. Why is it when there's a 15-minute wait to get through the line, do you not remove your cell phone, keys, and change from your pockets until you are standing right in front of the X-ray machine? People, you have time to prepare. Do so.
Well, for my rant today, when scheduling a full conference get-together after hours at a conference, I just like to say that it is not necessary to amplify a band that has 4 guitarists, 1 harmonica/singer, and 1 drummer. Sometimes people just want to talk to one another. That's all the time that we have for today. Thanks for watching. Thanks for listening. You can find us on Twitter at Quansight AI. If you're interested in funding open source projects like PyMC3 and PyMC4, you can find all of the project roadmaps at quansight.com/projects. Chris, where can people find you and PyMC3?
The best place to go is pymc.io to see our fancy new website, and then also join in the discussion at discourse.pymc.io.
Well, thank you so much, and join us again next episode, everyone, for a salty discussion on pyodide. Bye.
Oh, that's a bad pun. Another bad one.